Hi guys, so we're going to start off today with looking at the formulas for the surface areas and volumes of spheres. It's two pretty simple, straightforward formulas. We'll take some notes first off of PowerPoint, and then I'll work out a couple problems for you on the whiteboard. As we're going along, please feel free to pause the video at any time and rewind it if you need to go back and listen to something a second time over. So first off, we need to review a little bit of vocabulary. So first off, you'll notice that a sphere, right, is technically defined as a set of all points which are equidistant from a given point called the center. Most of you are used to seeing this. Our sphere, if you can imagine like this, has a center that would be right about there. And then all of the points in that sphere are the same distance from that center point. Then you'll also remember that a radius is defined in a sphere as a segment that has one endpoint in the center and then the other endpoint on the sphere. And remember, it could be along that equator, or what we call the great circle, or it could be along any other point in the sphere. Then lastly, a diameter, many of you guys will call it twice the radius, and you'll remember that that's a segment that passes through the center, but has endpoints both on the sphere. The next one that you want to worry about is some essential ideas on this one. One of the things that you know already, but I want you just to think about, is to imagine that if at any point I take the sphere and I slice through it with a plane, then I would be given a circle on that plane. Second, also, if that circle of the plane intersects through the center of the circle, you have what we call a great circle. So you can kind of imagine that that's the circle that's formed when you touch all the sides and go through the center of the sphere. Really, to kind of give you a good idea of that, you want to imagine like the equator on the earth is a great circle. The nice thing about a great circle is that the circumference of the great circle is the same as the circumference of the sphere. And then also a great circle divides that sphere into two hemispheres, just like we have on Earth. You have a great circle in the middle and then a northern and southern hemisphere. Now the important piece that you absolutely have to have written down in your notes, if you notice over here I'm putting that little notebook icon there, that's so that you should know that at the very minimum you should have this in your notes. So the first is the theorem for the surface area of a sphere. Remember, when we're talking about surface area, it would be like the plastic coverage of the sphere, not the contents on the inside. It's a two-dimensional idea, if you will. It's just the outside covering, if we'd say wallpapered or painted the sphere. So you can see here surface area equals 4 times pi times the radius squared. And it shouldn't surprise you at all, since we're looking for an area formula, that the radius is then squared. So again, the surface area of a sphere is 4 times the product of pi and the square of the radius of the sphere. Okay, our next important theorem is to talk about the volume of a sphere. Remember, again, the volume would be what would happen if I took the sphere and filled it with, say, water or cereal, like Miss P likes to do. To find the volume of that space, we're going to take 4/3, which is our magic number, our 4/3, times pi times the radius cubed. So you can see, again, the volume of a sphere is 4/3 the product of pi and the cube of the radius of the sphere. Remember, again, that radius is from the center point to the edge, just like the radius that you're used to seeing in a circle. Okay, once you have those two written down in your notes, we should be able to go ahead and do a couple formulas. Great, guys. Good to see you back. We're over here now to our whiteboard, as you can see, and I have a problem for us to solve. So once again, we have a sphere, and our sphere this time around has a diameter that's 10 meters across. And you can see our question for us is, what is the surface area in terms of pi for that sphere? A few things that you might want to note as we're going through. In terms of pi here are often the best words that you can see. That means you don't need to multiply it out. You can leave pi in the answer. And then the second thing is we also want to make sure that when we're looking at this, that 10 meters is the diameter, not the radius. So we want to kind of write ourselves a note here that says 10 meters equals the diameter. So when we look at that, the first thing is we say, well, what's our formula for surface area? And you should look back to your notebook and be able to remember that the formula for surface area is surface area equals 4 times pi times the radius squared. So it should be pretty simple, straightforward, what my old math teacher used to call plug and chug. So if 10 meters is our diameter, we know that our radius would be half of that because 2 times the diameter is the radius. So I can take this, simply divide it out, and I'll know that my radius is 5 meters. Radius plugs right in here for radius, and we are all set to go. So surface area equals 4 times pi times 5 squared. Plug in our numbers, and we end up again with surface area equals 4 times pi times 25. 5 squared is 25. And then we move down to the next one. 4 times 5 should give us 100. And then we end up with the surface area equals 100 pi. Since they asked us to leave our answer in terms of pi, we are perfectly good with an answer of 100 pi. That's probably about the simplest surface area problem that you'll ever be asked, but it's a good way to start.